Electrons are always moving between objects. Even as you watch this on your computer, there's electrons moving from the keyboard to possibly your hands or maybe your shirt. Electrons are always being transferred. There are three main methods that electrons move in and out of an object and therefore charge it or make the object neutral: friction, conduction, induction, and grounding. Friction is what happens when you put your hands together and rub them for a while. You feel the heat. So when you rub two objects together, they resist each other and they create a heat. Friction can cause electrons to be pulled from one object and added to another object. The key to understanding why friction allows electrons to move is by understanding the word electron affinity. So you're going to hear affinity quite often. Affinity is an atom's propensity to gain an electron. So it's basically how much an atom can take electrons. If they have a low affinity, then they don't really want electrons, and if they have a high affinity, then they really want electrons. So in this periodic table, you'll see how the general trends for affinity work. Oxygen, fluorine, these atoms, these elements here really want electrons, while way down here you have elements that do not want them as much. One of the main reasons why electrons transfer with friction is because different objects have different affinities for electrons. So here we have two objects. So if we take the high affinity object and you take it over here, it's not just touching but rubbing. It's the force. It's called electrostatic force, and it rubs here. It creates friction. Now this friction will cause an electron from the low affinity to jump over to the high affinity. Now we have charged the object on the left. It has 6 negative electrons and 4 protons, therefore a net charge of +2. While the object on the right has a net positive charge because it has 2 electrons that are negative and 4 positive protons. This is a simulation from a website called SimBucket, and it's a great example of how friction can cause an item to be charged. So here's a balloon. It tends to have a high affinity for electrons. And this is a wool sweater which has a low affinity for electrons, so it tends to give up electrons. And as you rub the balloon on the sweater, you will see the electrons move from the sweater to the balloon. So the balloon is now charged. It has a net negative charge and the sweater has a net positive charge. And because the balloon is negative and the sweater is positive, they attract, as you can see. The next method of charging an object is conduction. Remember, to charge an object is to give that object a net charge, negative charge or positive charge, to make it not neutral. Conduction is the transfer of electrons by touch between two materials. Here we have two objects. They're both conductors, they're both made out of metal. The one on the left is negatively charged. When it touches the one on the right, the electrons flow into it, and notice how the electrons disperse evenly through the conductor on the right and the conductor on the left. Now they are both charged, negatively charged. Let's talk about why they're both negatively charged. So here we have two neutral conductors on the left and right. These are made out of, this is both metal, so let's say they're made out of aluminum, and if they touch, they are now one object. Because they're both conductors, this becomes one aluminum piece of metal. Now they're both neutral, so nothing changes. There's no electrons to be exchanged. Everything is neutral, so everything stays the same. Now on these ones, let's do something a little different. Let's say the one on the left is charged. It has a negative, 4 negatives. Now notice when I put these negatives in, I spread them to the 4 corners because the negative charges try to get as far away as possible from each other. So this is negative. On the right, this is neutral. Now let's have them touch. When they touch, they become one. So there's no longer any separation here. The negative charges now have all this new real estate to spread themselves out. And this entire object wants to disperse the negative charge as much as possible. So these electrons are not going to stay over here. Instead, they're going to spread out to the four corners of the entire object. Now we have spread the charge completely through conduction. The entire object would now be negative. If we were to split these back up though, and they are now separate pieces of material again, notice the one on the right is now negative. And the charges would go as far away as possible from each other. So both items are now charged by conduction.